So now that we have a good understanding of parent functions and how they act in relation to each other, we're going to talk about some inverse functions, and this will help us to solve some equations and to understand our next unit on logs and exponential functions. So there are three ways to describe the relationship between inverse functions. These ways are using tables, graphs, or equations. And we're going to go through each of these using a similar example, and then you'll see some other applications for it. So first I have this example right here. I have this table of x and y values. X is 1 when y is 2. X is 2 means y is 3. 3 is 4. And 4 goes to 5. The idea of an inverse function is usually we have x, we say it maps to y. So we take an x value, we put it into our function machine, and we get a y value. The inverse function does the exact opposite. It undoes what the function does, which means we take the y value and we map it to the x value. So here the opposite would be, instead of putting in 1 and getting out 2, when we put in 2, we're going to get out 1. When in the function we put in 2 and we get out 3, that means that in the inverse we put in 3 and we get out 2. And this will continue all the way around. So we're just redefining the function. So instead of mapping from the x to the y, from the domain to the range, we are now mapping from the range to the domain. So it's a new function in its own right, but it's related to this in that it is mapping in the opposite direction. And that's just flipping the x and the y values. Another way to represent this is graphically. So here I have that same function graphed out. I have when x is 1, y is 2. When x is 2, y is 3. X is 3, y is 4. And x is 4, y is 5. So I'll make that function right here. And that'll continue like this. Now when we're switching our x and y values, that's the same thing as flipping over the y equals x line. So right here's our y equals x line. That is when y is 0, x is 0, when x is 1, y is 1, all the way through to infinity. And when we're creating an inverse function, we're just flipping over this line. So we're taking a value here and reflecting it straight over that line. And we're doing that with every point. So now, instead of when x is 1, y is 2, we have that x is 2 when y is 1. Instead of when x is 2, y is 3, when x is 3, y is 2. And this is a simple example, but it's all going to work in the same similar way, in that we're just going to take all of the dots on our original function, reflect it over the y equals x line, and create our inverse function. And these will extend either direction to infinity. The third way to understand the same idea is using an equation. So if we look back at this graph, and we can also look at the graph that we made for it, we can find that the equation of this line is I'm going to take my x value, I'm going to add 1 to it, and I'm going to get my y value. X value plus 1 is y value all the way through. So if I were to write that out as an equation, I would write that y equals x plus 1. It's a really bad plus, but that's okay. Ooh. So y equals x plus 1. And that's consistent with the graph that we have on the previous page. This is x plus 1. It's got a slope of 1 and a y-intercept of 1. Now in order to switch that across, we're just going to switch the sign. So to go from 2 to 1, that's subtracting 1. To go from 3 to 2, that's subtracting 1. 4 to 3, again, we're subtracting 1. So if I were to write out the inverse function, I would write that y equals x minus 1, which again is what we see in this graph here, where we take our values, we flip over the x and the y, and we see that we have a slope of 1 and y-intercept of negative 1, which is the line y equals x minus 1. So now we're going to go over algebraically how this would happen. So if we have our equation y equals x plus 1, and I want to know what is the inverse function. This one's not too difficult to think of, but we're going to talk about how you might go about finding it algebraically, because it might get harder. So what we're going to do is we're going to switch the x's and the y's, just like we did in the table. And instead of y equals x plus 1, we're going to have x equals y plus 1. I just took the x and I took the y and I flipped their locations, which is essentially what we're doing both in the table and in the graph, flipping the location of x and y. And then I can solve for y. Subtract 1 on each side, and I get x minus 1 equals y, or as we wrote it previously, y equals x minus 1. Now, an important thing I want to think about now is the inputs and the outputs, and I want to draw them out. So what we have is y equals x plus 1. This is my function. I'm going to call this f of x. In my inverse function, which we write f to the negative 1 inverse of x, I'm going to have y equals x minus 1. Now when I put in points, I find that I have, let's say, for example, 2 equals 1 plus 1, of course. Here, in the inverse, we have 1 equals 2 minus 1. So just like we've been doing throughout the entire video here, we're switching the x's and the y's. So wherever the x is here, switches to where the y is. So when you think of it in colors like this, you'll see that when we're going to the inverse function, it's just a matter of switching the two x and the y values in whatever location they need to be in. So again, here, if we have 3, that's going to equal 2 plus 1. And if we were to flip it into the inverse, we would get 2 is equal to 3 minus 1. Now I want you to consider the function f of x equals 2 to the x.
This is an exponential function. Using the three methods that we talked about, what is the inverse of 2 to the x? Find it graphically, find it with some points, and think about it with algebra. Next class, we're going to talk about how to use algebra to solve a question like this.